Welcome to today's class. Today we are going to look at linear expansivity. Please, if you know anyone writing JAMB this year 2025, share this video to the person, invite the person to like this video, subscribe to this channel. We have started tutorials already. We have started topic by topic, answering past questions, preparing students on how to tackle questions for this year's JAMB physics, especially for JAMB 2025. Today we are looking at linear expansivity. Look at this interesting question. A meter rod 800 millimeter long is heated from 10 degrees Celsius to 95 degrees Celsius. If it expands by 1.36 millimeters, the linear expansivity of the metal is. Before I solve this problem, I want you to note that linear expansivity is the increase in length. L1 is the original length. This is the final length. The increase in length per original length per degree rise in temperature. This is the formula you can use to solve problems on linear expansivity. Then another thing I want you to note is that when you are asked to find the new length L2, you should use L1 into 1 plus alpha change in theta. Change in theta is the change in temperature. This is the linear expansivity. Then 1. We have factored out the new length from this formula to make it very easy when you want to solve JAMB questions, so that you don't waste time calculating, wasting so much time. You just apply this second formula. Sometimes they can ask you to find the safety gap. The safety gap is that L2 minus L1. These are the key things you need to know on this topic, linear expansivity. Without wasting much time, I want you to know that the unit of linear expansivity is per Kelvin. It is different for different metals. The one of steel is different from that of iron, brass. They all have their linear expansivity. Also note that we have area expansivity is related to linear expansivity by 2 times linear expansivity. Sometimes in the question, if linear expansivity is not given and this is given, you can find. Then there is also volume. Cubic expansivity is 3 times linear expansivity. Remember, when you talk about linear, you can have it in cm or meter. When you talk about area, you have it in meter square. Then when you have volume, volume is in cm cube or meter cube. So you see 3 times and 2 times. Once you note these things, you will not waste time or have any issue solving problems on linear expansivity. Let's take this example. A meter rod 800 meter long is heated from, it means giving L1 is given as 800 millimeters, is heated from 10 degrees Celsius to 95. It means that theta 1 is 10 degrees and theta 2 is 95 degrees Celsius. So we can get the change in temperature to be 95 minus 10, which will give us 85 degrees Celsius. If it expands by, it means that L2 minus L1, the expansion is 1.36 millimeters. The linear expansivity, this is what we are looking for. Now you see all that we have. Let's put it into this equation that alpha is L2 minus L1 over L1 change in theta. Let's put in everything. If we put in, we are going to have L2 minus L1 is already giving us 1.36 millimeters over L1. L1 is giving us 800. The change in temperature is 85. So we'll go ahead and calculate this to get Our final answer as 2.0 times 10 raised to power minus 5 per Kelvin. If you have it in per Kelvin, that's the standard. If you say it in Celsius raised to power minus 1, is also correct. Depends on the option that is given. So let's take another example. Let's look at the second example. Meter rods of length 2 meters each are laid end to end to form a bridge at 25 degrees Celsius. What gap will be provided between consecutive rails for the bridge to withstand 75 degrees Celsius? You can see the change in temperature already. Now, what are we looking for? We are looking for that gap. Remember what I told you at the beginning of this video. Please, if there is any topic you want me to do video on, just drop it at the comment section. Give me the topics you want me to handle and I will do videos and tutorials on them. Please just check the topics you're having issues in physics and mathematics. Drop it in the comment section. Now, giving linear expansivity is already given. And then we are looking for L2 minus L1. And the change in temperature. The change in temperature is 75 minus 25, and that's 50 degrees Celsius. And what again? The original length is giving us 2 meters. So we just apply our formula that linear expansivity is L2 minus L1 over L1 changing theta. And when you do that, just get the safety gap, which is L2 minus L1. And that will give us alpha L1 change in theta. So we are just multiplying everything. Alpha is 2 times 10 raised to power minus 5 times L1, which is 2, times the change in temperature, which is 50. So what do? We'll multiply all through, multiply everything together to have, going to have 2 times 10 raised to power minus 3 meters as the final answer. Please make sure you like this video, share it to someone preparing for JAMB this year, and subscribe to this channel for more videos. Thank you.